time. So
Yeah.
Wow.
I just launched the application and now it waits for the server. At some point it will get the connection and then it will start. Hopefully.
Yeah, and
I'm not in the. That's good. I'm not in the.
As you can see, each bar starts growing with
laboratory.
each number has been processed. And when the bar turns red, it's because the device closed the application and left the pool of workers. The thing we wanted to do was to be able to leave at any time. So as you see the number 90 down there left, and I can join in again. And as you will see, number 90 will start again as a new bar because it started a new session. It's still looking for the server, so it will take a few seconds probably to find it. As long as it's connected to the same Wi-Fi, that is, it should be.
The server broadcasts.
Yeah. The thing is that the server is sending a signal so the clients can find it and join in.
There you go.
So there it finds it and it starts.
So where's our 177?
So another
started the 13.
Another important property is that even if I kill one of these applications, the number is not lost and the server will retry the same number with any other available device. So no number is lost in this process.
And I actually see there that the computation is really distributed and asynchronous because you see, for instance, the 23rd numbers being found after the 509.
It's interesting, this is really interesting experiment to me. We're just in meeting with the Secretary of Science and Technology, and one of the things we're talking about, sort of related to QNX, is that BlackBerry's future is much beyond just smartphones. And the example I used is you go into a hospital and you have many different devices measuring blood pressure and something on the same patient, but in many hospitals they're not connected to each other, and so a doctor will come and people are writing down this much blood pressure and this much drugs over here, instead of having everything integrated and coming together on a chart which could be on your BlackBerry at the end of the desk, and you've just done what we've talked about.
This is really important because right now you have 1 billion devices all over the world. And if you can resolve one mathematical problem in this case, or one scientific problem distributed in those billion devices, you have a power of computing that it's uncompared.
So you have several brains working at the same time.
Exactly. They are working in parallel, trying to solve
the operating system that's in this playbook is no different than the operating system that we could put into a blood pressure monitor and into whatever, and then those different valuations could come, cross-tabulate against each other, and then you can make proper diagnosis on how to cure a patient. And the patient might be at home instead of in the hospital. And so,
yes, one thing that so this platform provides that is not the case with others is that I can do some other things.
yeah,
As it's really multitasking, it continues computing. It's not that the application freezes and it really continues doing.
I would love to hear if your experience in working with the new BlackBerry as well, if things like that multitasking, if there's any thoughts that you have, what you like, what you didn't like, and those things too would be interesting as well.
Well, this is one thing that we liked. One thing that we still a bit confused is this network connectivity that we've been experiencing in comparison, for instance, with Android. That Android devices connect very much faster, much faster to.
They connect faster.
They connect faster to the network than the BlackBerry ones. But we don't, let's see, we have to be careful with, at the same time I said this, I want to be careful because we, for this application, something that we didn't say is that Gervasio ported Qt because we don't have cascades and all this framework on the, so to make just one application to run on both playbooks and C10, we ported, he ported Qt, and so it's in Qt, and so we don't know.
That's interesting.
Then maybe we try cascades or other API to connect to Unix, maybe it's faster. We don't know. So that's but that's one of the things that we would like to closely investigate.
Sure.
See that's what
This is really important. In these times, like everybody's talking about the cloud, and all information is in the internet, and our our devices start to be like non-intelligent devices, because everything is in the cloud. This is what's gonna be a revolution, because you have the power of processing in your device, and if you can spread that into the billion devices,
your collective power is extraordinary.
Exactly, and there are a lot of really good samples. Like there is one application that somebody did that they distribute the processing need, and they found I think in 2 weeks they found something that the science couldn't find in years.
Yeah. Or think, for example, we were talking about how our QNX system is now in 60% of the car brands in the world. So as the automotive population turns over and we get that distributed computing power connected together, and we're a leader in all those types of things, the joint computing power of all those cars that drive us crazy because we can't get somewhere, we might actually be able to find a way to move them faster.
Okay, we have a network problem.
You didn't see any.
It's a network problem.
Never do a live demo.
Yeah.
That's the way it is.
But yeah, definitely with cars, this is the way you can connect cars so they can talk each other in a collaborative way.
And use that, that collective computing power all of a sudden becomes awesome. Yeah.